Hello everyone. Today we want to learn the demonstration of verification of impedance and current of RL, RC and RLC series circuits. That is as per our autonomous structure, one of the experiment in basic electrical and electronics engineering laboratory. So the heading itself indicates verification of impedance, that is denoted by capital Z, and the current of all the combinations of resistance inductor which are connected in series, resistor and capacitor connected in series, and all the three components resistor, inductor, capacitor which are connected in series combination. So already we learned the analysis of these RL, RC and RLC series circuits in our theoretical part. Now today we will verify the values in laboratory by conducting an experiment on verification of impedance and current of RL, RC and RLC series circuits. So what are the operators required for this experiment? You can visualize here: resistors, inductors, capacitors having a range of 25 ohms resistor, 110 millihenry inductor, 160 microfarad capacitor. And of course the AC power supply, that is a 30 volts we are taken with a current rating of 1 ampere. A few connecting wires in order to make the circuit. So see the circuit of RLC series circuit. So first we have to go through with RL series circuit like this, both are connected in series. Later we will go for RC series circuit, and then we will shift to all the three components which are connected in series, that is RLC series circuit. Right. Now we will go with the experimental setup. So this is your hardware kit. Verification of impedance and current of RC, RL and RLC circuits. So here we can connect either in series combination or parallel combination by using the connecting wires. But in our experimental setup we are having only RLC series circuit. So first I have to connect the experiment for the circuit of RL series circuit. So for that, see, I am giving the supply terminals of 30 volts AC. So positive to positive and negative to negative, the supply terminals are getting connected. Now in order to measure the value of current, I need to connect one ammeter which is always in series connection. So ammeter connected in series, and ammeter second end is connected to your resistor. See here in resistor. So here in between this supply and resistor, I am going to connect one ammeter here. So by connecting this ammeter in series, so it should be going to measure the amount of current flowing through in the series circuit of RL. Now the resistor second end which is connected to the inductor first end, since these two are connected in series combination, and the inductor second end is connected to our negative supply terminal. Done the connections of verification of current and impedance of only RL circuit. Here I am connected. Now we will verify the readings. So by switching on, so give the voltage value in the ranges of 10 volts, 20 volts or 10, 15, 20, 25, max up to 30, since we are given 30 volts supply. So here I am varying the variac of 30 volts up to 10 we can take. Right. See the voltmeter display reading 10 volts. Corresponding current is 0.152. So that you have to note it down in the tabular column of RL circuit. So in the first row across RL circuit, you need to mention the voltage value as 10 and current reading as 0.152. This is your current reading, this is your voltage reading. And then we need to calculate the impedance. And then we need to calculate the impedance value. So the impedance Z, what is the formula? We know the impedance Z is equal to nothing but which offers the resistance, or we can also call it as which offers impedance to oppose the flow of current. So where the impedance parameter is to oppose the flow of current. So we know from Ohm's law, I equal to V by Z. So from this Z equal to V by I. You know the value of V? from the display, that is 10 volts, and the value of current, that is 0.157. So therefore by substituting these two readings here, let us write, I am getting some 10 volts and 0.152, and the formula of Z is equals to V by I, that is V value is 10 by 0.152, you will get some value. You need to mention that value of Z here. So by this, our RL series circuit verification of impedance value and current value is completed. Then we will go for RC circuit. RLC you can take the one more reading like this. Like just I am increasing to 15. So for 15 I am getting 0.275. The same you need to mention here in your observation. So first reading I am taken as V value, I value, Z value for RL series circuit. V as 10 I got and I as 0.152. Z you need to calculate as V by I. Similarly for second reading I applied 15 volts. That should be around 14.9, in the sense approximately I taken as 15, and it should be 0. See, for 15 volts it should be 0.275 amperes. 0.275. So again you need to calculate impedance, Z equal to corresponding voltage by corresponding current. So like that we can take n number of readings. That should be maximum, we can go up to 30 volts. So by this our verification of impedance and current values for RL circuit is completed. Now we will see the RC component. So by making the variac to minimum position and turn off, and we will just going to connect the RC. So that means we need to remove the inductor. So the resistor second end, which is going to connect with capacitor first end. So the resistance second end, is going to connect to, this is the resistance second end. This is the resistance second end, which is connected to capacitor first end, and the capacitor second end is connected to our negative supply terminal. Done. See, once the connections, the supply is provided 30 volts, and ammeter is going to connected in series, and this ammeter second terminal is going to connect to resistance first terminal and resistor second terminal. Where it is, the resistance second terminal is going to connect with capacitor. The resistance second terminal is connected to capacitor first terminal. Done. Capacitor second terminal is connected to negative supply terminal. Now turn on it. So after turning on, the same procedure we need to apply some 10 volts. So by applying 10 volts, how much current is going to drawn by RC circuit, we need to verify here. So I am varying up to 10. Slight variation, 9.7 and 10. So for this I am getting the value as, see, the voltmeter value I am getting 10 volts. So the same here I am writing as 10 volts. And the current how much displaying the ammeter? 0.164. So 0.164. So therefore Z you can calculate with the same formula of Z equal to V by I. So in that same manner you can increase the voltage value and take one more reading for your reference. Now I am taken around, it should be 15 volts, so 14.9 or 15 volts, it should be 0.242. Like that we can take the number of readings. So by this verification of current and impedance of RC circuit is completed. Now taking the variac to minimum position and turn off the circuit, the power supply. Now we can going to connect RLC series. So RLC series circuit, so R value remains the same. So C should be going to remove, and from the resistance second terminal, so the resistance second terminal to inductor. So resistance second terminal to inductor, and inductor second terminal to your capacitor first terminal, and the capacitor first second terminal to your negative voltage supply. Now once again at 10 volts, how much for 10 volts? We are getting 0.304. So the same here you need to write 0.304. So again calculate the impedance value, right? Again we need to calculate impedance value as Z equal to V by I. So in the similar manner you can also take the one more reading just for cross checking of verification. Take some 15. So it should be around 15.1 or 15.2. So we are getting 0.44. So that will be fine. So you need to note it down one more reading, and then the observation readings tabular column is getting completed for RLC.